The Being an Engineer podcast is a repository for industry knowledge and a tool through which engineers learn about and connect with relevant companies, technologies, people, resources, and opportunities. Enjoy the show.
In the ag industry, cost is key. So quite often you'd get to a point in your design where you'd have to step back, realize where your tolerances would stack up, and if it was achievable with a looser tolerance, you'd take that approach in hopes that you could save some dollars in the end.
Hello everyone, welcome to the Being an Engineer podcast with your co-host Rafael Testai. Today we have Michael Kaeding. He's an experienced product engineer with a demonstrated history of working in the machinery industry. He's skilled in various 3D modeling software such as SolidWorks, Autodesk, and Inventor, and he enjoys providing practical, easy-to-use pieces of equipment for a variety of customers. I know that's vague and open-ended, and we're going to talk about that in the episode. Michael received his Bachelor's of Applied Science, focus on mechanical engineering from the University of Saskatchewan. Can you help me pronounce that, please? How do you say that?
Saskatchewan.
Perfect. So, Michael, welcome to the podcast.
Thanks for having me, Rafael. It was interesting to get the invite, and I'm looking forward to our conversation.
Yeah, tell me about the invite. What was interesting about it?
I guess I didn't expect, a farm boy from Saskatchewan who has his engineering degree to come on the show with the likes of some of your other past guests that have gone to MIT, Apple, all those very distinguished guys.
Thank you very much. I think we want to give our listeners the full range of engineers and perspective because there are other people listening who may very well relate to your history and what you work on. So let's start out with the difference between designing for high volume in large agricultural equipment and custom heavy-duty industrial settings. You want to talk a little bit more about that?
Yeah, absolutely. So I guess coming out of university, I joined a agricultural company here in Regina and did a bunch of machine design with them, ranging from conveyors, grain carts, grain vacs, a wide range of things. And throughout my years of experience there, I came to realize that you had to pay close attention to what was actually required. In the ag industry, cost is key. So when you were designing something that had a pin connection or something of the like, a bolt, you had to take a step back, think, was a super tight tolerance required? Because those super tight tolerances often lead to expensive parts. You're into the drilling or reaming versus just using a laser cut hole that would suffice in the application. So quite often you'd get to a point in your design where you'd have to step back, realize where your tolerances would stack up, and if it was achievable with a looser tolerance, you'd take that approach in hopes that you could save some dollars in the end. Then switching over to my current role with Rockford Engineering, we do more of a custom one-of builds where the reliability is more key and you need to focus in on, I guess, also thinking to the size of equipment we develop. It's quite large and quite heavy, so some of those sloppy connections don't hold up over time.
When you say quite large, are you talking about maybe like a John Deere, something in the field? What do you mean by large?
I guess for the general audience, if they were to look up, say, a Sandvik underground scoop, would be a good reference. That's kind of one of the larger pieces of equipment that would operate in an underground potash mine in Saskatchewan. That's who we primarily call on for our mining equipment, is local here in Saskatchewan. So those scoops would be a large piece of equipment along with the miners themselves, which are upwards to, I think a 4-rotor miner is about 250 ton.
Okay, I'm pulling up the specifications right now to get an idea, but it looks like to be a very large orange truck, basically.
Yeah, quite often it's pretty low profile because you only have, I think it's about 8-9 feet maybe of clearance to fit through.
I see it. Okay, it's almost like the what do you call it? I only know how to say it in Spanish. It's called Batimóvil, which means Batman's vehicle, basically.
Right.
Batmobile. Batmobile, is that what you call it?
Yeah, Batmobile. Yeah.
Yeah, like that. So it's like low to the ground. So it's like a big truck, very low to the ground, and it's orange. Civic Underground Scoop. That's what I Googled right now.
Yep.
You talked about ag, and anytime we say ag industry, just for the listeners, it means agricultural industry. And this is not something that I'm very familiar with because here at Pipeline, where I work at, that's sponsoring the podcast, we do test fixtures for medical devices. So this is way out of my field and things that I'm used to talking about. So this is all new to me, and I'm learning just as much as some of the listeners are. But you talked about machine design. Could you tell us about what machine design is and how do you get good at it? The more specific the advice, the better.
Machine design, that is a good topic. You can get quite broad. The machine operates setting some parameters, and you can get down to the nitty-gritty details of specific shafts and what they look like. I like to consider machine design, I think there was a saying along the lines of mechanical engineers, what is it? They design things to move. I forget. It was a good quote, but something along the lines of, we can dabble in almost anything. So you've got machine design right from a bearing and a shaft all the way up to, a fairly complicated multi-part system where you're getting into like a full piece of mobile equipment.
Okay. What's your specialty when it comes to machine design, and how did you come upon that specialty?
What would be my specialty? I guess I've taken a key interest in, shaft design, stress analysis, hydraulics. I would say those are probably my top 3, what I enjoy doing. And I think that all kind of stems back to my upbringing on the farm. Driving tractors and equipment like that, I was fairly exposed to it at an early age and spent some long days thinking about how things could be improved on the pieces of equipment that I was running.
Did you ever get to design something that improved one of the pieces of equipment that you were contemplating as a younger adult when you were in the farm?
Yeah, absolutely. We had a grain farm, so we had augers and grain carts and conveyors. So I was able to work on lots of those and take some of my knowledge and from my upbringing and apply it to that situation, kind of already knowing what would and what wouldn't work and what the end user would think of it as I was going through the design process.
So machine design is also a field that I'm in, and it involves making mechanisms on CAD and software and then bringing them to reality. You send it to a machine shop and then you assemble it, and that the machine all works together as intended, hopefully, or you make some revisions. What was a step in your machine design career that gave you a breakthrough, that took you to the next level?
I think I had one experience when I first started at the ag company. I think it was one of the first jobs I was given. I was to model up these pieces of sheet steel and get a prototype on order. And I was fairly inexperienced using the CAD software, so I modeled it up and threw in bend lines manually, and ended up that all of my sheet metal parts were bent backwards because I didn't have a good appreciation for what those drawings meant to the guy that was making the equipment or making the sheet steel. That definitely triggered something. I like to try and keep, the manufacturing process in mind as I'm going through the design. Is a tool going to be able to fit in here? You always want to try and make sure that you're designing something that's practical for not only the end user, but the guy that has to make the part that fits in there.
So as an up-and-coming engineer, if we don't want to make a mistake that's going to cost our employer hundreds or maybe thousands of dollars, is there something that we can do on our way up through college to better prepare ourselves so that when we join the workforce, we don't make mistakes that a beginner machine designer would make?
Yeah, absolutely. You can, I would think my best piece of advice is just be curious. Ask a pile of questions. Lean on the more experienced guys and get their feedback throughout your design process. Run every little thing past them if you can. Get their feedback and just get a better appreciation for how other people's minds work and how they would change one small thing that may pay off big time in the end, as well as it saves you a bunch of rework time, if you have to remodel something back down to a base part. If you can get ahead of it at the start, it'll save you a bunch of time.
So let's say that you're someone that has your SolidWorks certifications, you know how to do a couple of mechanisms, and now you finally get your contributor in a company, and they assign you a task that's machine design related, and you want to make sure that you do the best you can and make a good first impression with your employer and your teammates at this company. How can you better prepare yourself for that when that moment comes? And this is advice you can give someone that already has their SolidWorks training, already has the basics down. What advice would you give them?
Probably the best advice, if you are in a company where, you do have an R&D division and you're doing prototypes and stuff like that, would be to get down on the shop floor and get the feedback of the employees that are putting things together. I can't even think of the amount of times that I received great advice from the assembly line workers or the R&D techs who were putting everything together, and was fairly straightforward with me as to why I did that, because I could have done it this way, which would save them a bunch of time in the end and was probably a better solution in the first place. Okay,
I like where this is going. So whenever you want to get that feedback from the assembly line or the machinists, how do you approach them? Because they're busy and you don't want to interrupt. How do you go about basically tapping them on the shoulder and asking them, how's that work?
I think I would suggest, just observing initially, just watching them work, figure out what they're doing. If something doesn't make sense, maybe make a mental note, and then if it comes to a time where they've got a little bit of downtime, you could step in at that point. If they're waiting for another part or they're nearing the end of their shift, you can maybe ask them why they did what they did. Is there any way that they think it could be improved? And I quite often found that they are more than willing to provide their input in hopes that it makes their life easier in the end.
That makes a lot of sense. And if you can't answer the following question, I understand, but the advice you gave takes into account a rather large company from the way that I understand your description, because you're going down to where the people are building it and assembling it. But what if you work at an engineering firm where they don't necessarily have the assembly line? They ship it out somewhere else and the assembly line is elsewhere. How do you get that feedback if you're a machine designer?
Yeah, that would fall in line with what we're doing here at Rockford. We don't have a huge engineering staff, and we've got half a dozen people out in the shop. But still, you could, if you can't get down to a shop, I'm sure there is more than one or two guys that would have experience somewhere else that could offer you some input. Even just, I know I've looked at a couple of other people's designs in the past, and it's triggered a question, and quite often has led to some pretty good in-depth discussions on why they did what they did. And quite often there's a bit of a middle ground that's found, where they can modify their existing design and come up with something that maybe they didn't consider, whether it's a range of motion that wasn't fully analyzed, that I've maybe highlighted could be a potential issue, and they've gone back and looked at things and resulted in tweaking it, and likely saved quite a bit of time and effort had that device been actually manufactured and put into the field to test.
When you review somebody's design, do you have a checklist that you follow?
Not officially. We've been kind of trying to work on a bit of a process of when we're checking designs. We generally try to do like a 5%, a 30%, 60%, 90% check if we can. On some of those big jobs, that's a little easier. Some of the smaller jobs, maybe it's a 25, 75. But if we can see it multiple times, it quite often will bring up some good points that maybe weren't considered and avoids that rework time afterwards.
Understood. Well, this seems like a good place for a quick pause to share with our listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. Well, my next question was going to be continuing a little bit more about design for assembly. That was one of the topics that we wanted to discuss for today, and we touched upon it. Is there anything else that you wanted to talk about when it comes to design for assembly?
I guess one of my tips and pieces of advice is always consider your tolerance stack up. Been bit more than once on that issue. And it's often an exercise that gets overlooked, but it can pay off if you at least look at a couple things and figure out if you're traveling down the right path or if you're going to have issues right off the start.
So if you're an engineer listening to this, and maybe you're on your way to becoming an engineer in college, and you haven't even come across, because a lot of the classes in college are very theoretical, calculus, physics, electromagnetism, and we have to take these classes. They're part of the degree, but we may never have come across the term tolerance stack up yet, and we don't know how to get training on it. So what should we look up online to get some good training so we can not make tolerance stack up mistakes?
That's a good question. I'm sure there's various YouTube videos out there. I know I've gained a lot of insight and knowledge from listening to podcasts. The internet is an endless amount of available information for you. I would also suggest, if you're going through university, to try and seek out some of the internships at local engineering firms. I know in the Regina area there's quite a few engineering firms or companies that would provide, summer employment, which would offer great opportunities to gain experience on some of these issues.
Perfect. Well, we're nearing towards the end of the podcast, and I want to talk about you have your certification in engineering, the PE, and you got it in Canada. And I was wondering if you could maybe walk us through the steps and how you achieved your PE license.
Yeah, for sure. Canada, I think, has a fairly streamlined approach. All the universities here, or major universities in Canada, generally are accredited by the, I think it's the Canadian Engineering Board. don't quote me on the actual title. I could get that for you if needed. But basically, all the universities are accredited, which ultimately saves you from having to write a competency. Yeah, saves you from having to write a competency test. So once you graduate university, you go out into the workforce, work under a professional engineer for 4 years, gain a bunch of experience. I know when I was going through it, Saskatchewan has changed just recently here to a bit of a different reporting style, but when I was going through, you had to write 4 reports on various engineering tasks that you completed throughout your years, and that ultimately was submitted to the Association of Professional Engineers and Geoscientists of Saskatchewan. They had a group set up there that would review all these experience reports, and they would either approve or ask you to elaborate on things before they approved them. And then once you had your 4 reports approved, you also had to take a law and ethics exam. There was a 1 or 2 day course followed up by an exam later on that you had to write and receive a passing grade. And then once you had the exam and all your experience reports covered, they issued you your professional engineering certification.
Okay, so professional engineering certification versus PE license, is that different?
I believe so. I think the PE designation is out of the States. I know when I did the law and ethics, there was a couple people that had come up from the States. So it's not fully transferable. However, the professional engineer in Canada is fairly transferable between the provinces in Canada. You just have to apply, and each province will reach out to their home governing body and make sure you're in good standing with them. And then it's a matter of gaining the ability to sign off on drawings outside of your home province.
Understood. Well, congratulations on your PE certification. And I wanted to ask you, is there something else that I should have asked you, but I haven't asked you yet?
Does it count with how cold the Saskatchewan winters are?
Are they very cold?
Yes, they're very cold. To the point where your car doesn't agree with you some mornings.
Jeez.
I think that's one point on the temperature scale where we can find a common ground, is that minus 40 degrees.
Freezing. Jeez. Well, how can people find you?
I'm fairly active on LinkedIn, so you can search me there, Michael Kaeding. You can also send me an email, which is mkaeding@rockfordworks.com.
Wonderful. Well, Michael, thank you so much for joining the podcast.
It's been a privilege.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.
Dear valued listener, we kindly ask that you help us get to 100 5-star podcast reviews in the platform of your choice. For a chance to win a $50 Amazon gift card, send a screenshot of your 5-star podcast review to podcast@teampipeline.us. You'll find that email address in the description of the show notes.